In this video, we're going to talk about some basic ways to solve equations. So we'll just look at some real simple examples. What we want to do is we want to think about the opposite order of operations, or PEMDAS in reverse. There are other acronyms similar to PEMDAS, but that's what I'm familiar with, which is parentheses, exponent, multiply, divide, add, and subtract. So we want to do that in reverse order. But if you do see parentheses where you can distribute, we want to distribute first to get rid of the parentheses. Okay, the parentheses is more if there's an exponent there or a more complex equation. The examples we'll look at here, the parentheses are just there for us to distribute. Okay, so we'll do that first. If we do see a fraction in our equation, if it's not by itself on one side of the equation, we want to get rid of the other terms so that we get the fraction by itself. Then we multiply to get rid of that fraction. And then whenever you see like terms, so if you see the same variable in more than one spot, if we can combine those terms, we want to do that to simplify our equation. Okay, so let's get into some examples. All right, so first we'll just do a real simple one-step equation. We just have x plus 3 equals 8. Pretty straightforward. We want to get the x by itself, right? So we want to get x equals, which means we need to get rid of the plus 3. So we want to move that 3 over to the other side. And so in order to do that, we have to subtract 3 on the left side, because now that'll become x plus 0, or just x. But we can't just subtract 3 on the left side, because that gives us a completely different equation. We need to subtract 3 on the other side. So I know a lot of people like to draw that line down the middle. And we'll just simplify this a little bit, clean it up. Okay, so we're subtracting 3 on both sides so that we move that 3 to the right side. And now on the left side, all we have is x. These essentially canceled. And on the right side, 8 minus 3 gives us 5. So x equals 5. Now, whenever you're solving like this, it's always a good idea to plug your answer into the original equation just to double check your work. So if we started with x plus 3 equals 8, and we said that x equals 5, plug 5 in for x, and we get 8 equals 8. Okay? All right, so I know that was very basic. Some of you might be looking to look at some multi-step or more complex solving examples. If that's the case, make sure to look at the description down below. Look at the example you're looking for, click on the time there, and it'll take you right to that example in the video. Okay, so next example. Let's do another one-step equation, or a simple one here. How about a fraction? So let's say we have 2x over 3 equals 12. Okay. So we said before, if we have a fraction in our equation and this is a fraction where the variable is part of the fraction, we want to get that fraction by itself. We don't have any other term here on the left side, so we can go ahead and get rid of that fraction. The reason that this is a fraction is because we are dividing by 3. If that 3 wasn't there, if it was just 2x, we no longer have a fraction, and we're okay. But because that we have divided by 3, it makes it a fraction. So the divided by 3 is what we want to get rid of. So the opposite of divide by 3 is to multiply by 3. Okay, so I need to multiply both sides of my equation by 3 to keep it the same equation, right? We're just moving things around, but it still is the same equation. So if we take 3 here, this is like 3 over 1 if we make that a fraction. And when we think about multiplying two fractions together, we multiply across the top and across the bottom, but we have this 3 times 2x and a 1 times 3. Because everything's being multiplied in the top and the bottom, those 3's cancel, right? And that's what we were looking to do to get rid of the fraction. So the left side we have 2x, on the right side we have 36. Okay, so we're slowly cleaning up the term with x. Now it's just 2x. Well, that's 2 times x. The opposite of times 2 is divide by 2. So divide both sides by 2. Half of 36 is 18. Okay? And I should go ahead and plug that into my original equation just to double check. Okay, so let's look at a multi-step equation. So now we've got the variable more than once. Okay? So we're going to go ahead and do go ahead and do this here. And I'm going to guess this is probably going to give us a fraction. That's okay. Fraction or a decimal is our x value. But again, that's okay. We're just worrying about the steps so that we can get x by itself. So there's a lot going on here. I see plus, minus. There's some multiplication here because we've got these coefficients, these numbers in front of the parentheses. So, like we said earlier, if we have parentheses here where we can distribute, we want to do that. Okay, and then we also want to combine like terms if possible, and that's just going to clean everything up and make it a lot easier to navigate what to do with our x. All right, so just this first term here, I can distribute my 2 inside, so 2x minus 2. And that is being added to this second chunk, which I can also distribute. So 4 times 3 is 12. 4 times 2x is 8x. Okay, equals 14. That looks better, but we still have a lot of pieces here on the left side. I notice that I've got 2 terms that have an x, and I have 2 terms with just a constant, a number. Okay, so I've got 2 sets of like terms I want to combine. So I'm going to start by, let's go red here, by combining 2x and 8x. So it's a positive 2x plus 8x. I'm going to add those together, and then we also have a negative 12, or excuse me, a negative 2 plus 12. Right, and that's all equal to 14. So 2x plus 8x gives me 10x. Negative 2 plus 12. That's the same as, I could flip that around and say 12, a positive 12 minus 2, or plus a negative 2. But that's going to give me 10, and that equals 14. Okay. Looking a little nicer again. Now we just have 2 terms. We always want to get rid of whatever doesn't have the x. So we want to get rid of this plus 10 here. So we're going to subtract 10 on the left because that's going to cancel that and give us a 0. But we have to do the same to the right side, so minus 10 there. So on the left side, we're left with 10x. On the right side, we've got 4. Last step is typically dividing, right? Whenever we have a number in front of x, so we have a coefficient of 10, we're going to divide by that coefficient, and I can simplify this a little bit and get 2/5, or you could say 0.4. There's our answer there. Okay? All right, I think we're going to do one more example, and this is solving for a variable. Okay, so sometimes you're going to have an equation that that doesn't have just one variable and the rest numbers. Sometimes you're going to have an equation or it's just all variables. And you haven't figured out what the values of any of those variables are yet, but you need to rearrange your equation accordingly, okay? So just take an equation that you've hopefully seen before. Area equals pi r squared. Okay, so that's the area of a circle. Well, we have two different variables in here, a and r. So maybe there's an instance where we need to get that r by itself, because we know the area, but we need to solve for the radius. Okay, I'm actually going to take a simpler one because that has a square in it. I'll just do the circumference. Pi times d, the diameter. So if we need to get d by itself, we do all the same steps that we did in those previous examples. We just can't simplify our equation at all because we don't have the numbers to do that. Okay? So if we want to get d by itself, we think of d as the variable we're trying to isolate, and think of everything else kind of like numbers. So how do we get rid of those terms? So if we've got pi times d here, how do we get rid of times pi? We divide by pi. Okay, so that pi cancels there, and now we have d by itself on the right side, and the diameter is just equal to the circumference divided by pi. Okay, I'll go one step further, and I will do this example here just in case you're curious for that. So if we're trying to solve for r, well, we got a couple things going on here. We've got multiplying by pi, and we've got that exponent of 2. Okay, so remember we're doing opposite order of operations, or PEMDAS in reverse. So we want to get rid of this pi first. We want to do the multiply component first. So that's the same thing that we did with the circumference formula or equation. Okay, and now we have this squared. It's the exponent, so that's going to be our last step. The opposite of square is square root. So if I take the square root of r squared, that cancels and just gives me r. But remember, we have to do the same thing to the left side. Now, there's nothing we can really simplify there with that left side. That's kind of the nice thing about solving for a variable, that there aren't as many steps to get what you need. It does make it a more complicated equation for the most part, but those two steps, and then we're done.